The welding torch hissed and spat blue-white light across the steel plate. It was 7:30 in the morning on November 12, 1942, and the men of the Permanente Metals Corporation shipyard in Richmond, California, were beginning another shift. Steam rose from coffee cups held in calloused hands, lunch pails clicked open, work gloves were pulled tight, and in Bay No. 1, the keel of hull No. 444 was being laid. This was not remarkable. Keels were laid every day at Richmond, at hundreds of shipyards up and down both American coasts. What made this particular keel different, what would make hull 444 remembered decades later, was a bet. Henry Kaiser, the industrialist who owned the yard, had wagered that his workers could build a complete 10,000-ton cargo ship in less than 5 days. Not just assemble a hull, not just launch an incomplete vessel. Build a finished, operational, seaworthy merchant ship ready for immediate service, complete with engines, wiring, plumbing, cargo holds, navigation equipment, and paint. The German Kriegsmarine, conducting their calculations in Berlin and Lorient and the concrete U-boat pens along the French coast, would have considered this impossible. Their entire strategic concept for winning the Battle of the Atlantic rested on a simple mathematical premise. If U-boats could sink merchant ships faster than the Allies could build them, Britain would starve, the Soviet Union would collapse without American supplies, and the invasion of Europe would become impossible. The numbers seemed to support this strategy. A merchant ship, they calculated, required 6 months to a year to construct. A U-boat could sink a ship in minutes. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. German naval intelligence had done their homework. They had studied British shipbuilding capacity. They had analysed American industrial output from the First World War. They had examined construction times for traditional merchant vessels built using conventional methods. Their analysts had produced detailed reports showing that even with maximum effort, the Allies could not replace tonnage faster than German submarines could destroy it. The mathematics were clear, the logic was sound, and the conclusion was inescapable. Germany would win the tonnage war. What they did not know, what they could not have predicted, was that the Americans were not building ships the way ships had always been built. They were building them the way Henry Ford built automobiles. Assembly line production, prefabricated sections, mass production techniques applied to vessels that had traditionally been custom crafted one at a time. And they were building them at a pace that would have seemed like fantasy to anyone trained in traditional naval architecture. Hull 444 would become the SS Robert E. Peary, named for the Arctic explorer. Its construction would be filmed, documented, and analysed. It would become a propaganda tool, a morale booster, and a very real demonstration of what American industrial capacity could accomplish when fully mobilised. But more than that, it would represent the moment when the German calculation broke, when the fundamental assumption underlying their entire Atlantic strategy proved false, when the mathematics that said they were winning revealed themselves to be based on outdated premises about how quickly a modern industrial democracy could produce weapons of war. The welders in Bay No. 1 that morning did not know they were making history. They knew they had a job to do, that there was a war on, and that ships were needed. They knew about the bonus pay being offered for speed. They knew their supervisors were watching the clock. What they did not know was that their work over the next 4 days would help answer one of the central questions of the Second World War. Could industrial production defeat military strategy? Could factories win battles that navies could not? The Battle of the Atlantic had begun the moment Britain declared war on Germany in September 1939. German U-boats, operating from bases in Germany and later from occupied France, hunted Allied merchant convoys, carrying food, fuel, equipment, and raw materials to Britain. The strategic concept was elegant in its simplicity. Britain was an island nation that imported the majority of its food and nearly all of its petroleum. Cut those supply lines, and Britain would be forced to surrender regardless of how many soldiers it could field or how determined its population remained. Admiral Karl Dönitz, commanding the U-boat fleet, had calculated exactly how much tonnage needed to be sunk each month to achieve this goal. His figure was 700,000 gross register tons per month. Sink that much shipping consistently, and British imports would fall below the minimum needed to sustain the war effort. Britain would face a choice between starvation and capitulation. The mathematics were brutal but clear, and for much of 1940 and 1941, the U-boats were winning. German submarines hunted in wolf packs, groups of 8 to 20 boats coordinating their attacks on convoys. A single U-boat would shadow a convoy, radioing its position to headquarters. Other boats would converge on the location. Then, at night, they would strike simultaneously from multiple directions. Merchant ships, slow and unarmed, had little defense. Torpedoes struck hulls, ships broke apart, men went into the cold Atlantic water, oil spread across the surface and caught fire, and the U-boats slipped away before escort vessels could counterattack. The statistics were devastating. In 1940, U-boats sank over 1,000 Allied merchant ships. In 1941, they sank over 800 more. Tankers carrying petroleum from American refineries to British ports burned and sank. Freighters loaded with food, aircraft parts, ammunition, and vehicles disappeared beneath the waves. Each sinking represented not just lost cargo but lost crews, men who died from hypothermia in lifeboats or went down with their ships when torpedoes struck without warning. British shipyards worked frantically to replace losses, but they could not keep pace. Traditional shipbuilding was a time-intensive process requiring skilled craftsmen. A merchant ship was built on a slipway with each plate riveted into place individually. Frames were constructed piece by piece. Engines were installed through complex lifting operations. Systems were hand-fitted. The whole process, from keel laying to launch, took 8 to 12 months for an experienced yard working at capacity. Britain had experienced yards, but not enough of them, and not enough workers, and not enough steel. The United States, still officially neutral, watched, with growing concern. President Franklin Roosevelt understood that Britain's survival was critical to American security. If Britain fell, America would face a hostile German-dominated Europe with no allies and no forward bases. But American neutrality laws restricted direct military aid. The solution was the Lend-Lease program, announced in March 1941, which allowed the United States to provide war materials to Britain without requiring immediate payment. Ships, aircraft, tanks, and food would flow to Britain as long as Britain could maintain its sea lanes. But Lend-Lease only worked if the supplies could actually reach Britain. And that meant ships. Lots of ships. More ships than anyone had ever built before. Ships built faster than U-boats could sink them. Ships built in quantities that would overwhelm German submarine production. Ships built so quickly and so cheaply that losing them to torpedoes became an acceptable cost rather than a strategic disaster. The question was whether such a thing was even possible, whether the industrial techniques that had revolutionized automobile production could be applied to shipbuilding, whether mass production could defeat submarine warfare. The man who believed it was possible was Henry John Kaiser, an industrialist who had never built a ship in his life. Kaiser had made his fortune in construction, building roads, bridges, and dams across the American West. He had been part of the consortium that built the Hoover Dam, one of the largest engineering projects in American history. He understood large-scale industrial organization, mass production techniques, and how to manage thousands of workers on complex projects. What he did not understand, and what would prove to be his greatest advantage, was traditional shipbuilding. Traditional shipbuilders were craftsmen. They had learned their trade through apprenticeships lasting years. They knew ship design intimately, understood the stresses on hulls, and took pride in building vessels that would last decades. Each ship was in some sense unique, fitted and adjusted during construction to account for variations in materials and slight differences in design. This approach produced excellent ships, but it produced them slowly. Kaiser looked at this process and saw inefficiency. He saw skilled workers doing repetitive tasks that could be standardized. He saw construction happening sequentially when it could happen in parallel. He saw craftsmanship where he needed mass production. The British had already begun moving in this direction with their emergency shipbuilding program. British yards had developed designs for simple, standardized cargo ships that could be built more quickly than traditional vessels. These ships sacrificed elegance and longevity for speed of construction. They were welded rather than riveted, saving time and weight. They used prefabricated sections where possible. They employed simpler propulsion systems. The British called them Empire ships, and they served adequately, though they were never built in the quantities needed. When the United States entered the war in December 1941, after the Japanese attack on Pearl Harbor, the shipping situation became critical. America now needed to supply not just Britain but also the Soviet Union through the dangerous Arctic convoys to Murmansk and Arkhangelsk. American forces deploying to Europe, North Africa, and the Pacific needed transport. The existing merchant fleet, already strained, was completely inadequate. The U.S. Maritime Commission, responsible for coordinating merchant ship construction, turned to Kaiser and other industrialists with a proposal: build merchant ships using mass production techniques, build them in new yards constructed specifically for this purpose, build them in quantities that seemed impossible. The design they would build was called the Liberty ship, based on a British design but modified for American production. The Liberty was not beautiful. It was a simple, boxy cargo vessel, 441 feet long with a beam of 57 feet. It displaced 14,450 tons when fully loaded. It could carry 10,000 tons of cargo in 5 holds. It was powered by a reciprocating steam engine, an old-fashioned design chosen because it was simple to manufacture and maintain. The engine produced 2,500 horsepower, giving the ship a top speed of 11 knots, about 12.5 miles per hour. It was slow, ungainly, and utilitarian, but it could be built quickly. The design used welding throughout rather than riveting, reducing construction time by 40%. It employed prefabrication extensively. Entire hull sections could be built in one part of the yard, while the keel was being laid elsewhere, then lifted into place by massive cranes. The engine, the deckhouses, even the masts and booms were standardized components that could be manufactured separately and installed as complete units. Everything about the Liberty ship was designed for mass production. Kaiser took this concept and pushed it further than anyone thought possible. At his Richmond yard and at other facilities he built along the West Coast, he hired workers with no shipbuilding experience. Farmers, teachers, women who had never worked in heavy industry, men too old for military service. He trained them in specific tasks, rather than teaching them the complete craft of shipbuilding. One worker would weld vertical seams, another would weld horizontal seams, a third would install electrical conduits, a fourth would paint. Each person became expert in their narrow specialty, and the assembly line moved forward. The Richmond shipyard operated on a scale that defied traditional understanding. The facility covered over 600 acres of land that had been tidal mudflats 18 months earlier. Kaiser's company had driven thousands of pilings into the soft ground, poured concrete foundations, erected steel frameworks for assembly buildings, and installed massive hammerhead cranes capable of lifting entire ship sections weighing hundreds of tons. By the time hull 444 was being laid, the yard employed over 90,000 workers across multiple shifts. The facility operated 24 hours a day, 7 days a week. Lights blazed through the night. Welding torches never stopped. The sound of metal on metal, the hiss of cutting torches, the clang of hammers, and the rumble of cranes created a constant industrial symphony that could be heard for miles. The workers themselves came from everywhere. Many were women, drawn by wages that were higher than anything available in traditional female employment. They worked as welders, crane operators, electricians, and pipe fitters. They wore work pants and safety goggles and learned to handle equipment that weighed more than they did. Some had been teachers or secretaries before the war. Others had been farm wives or shop clerks. The shipyards trained them in a matter of weeks for jobs that would have required years of apprenticeship in traditional shipbuilding. A woman named Beatrice, who had been a seamstress in Oakland, learned to weld vertical seams on hull plates. She could lay a bead that passed inspection on her third day of training. Within 2 months, she was teaching others. The prefabrication system was the key to the entire operation. Rather than building a ship from the keel up in sequential stages, Kaiser's yards built ships in sections simultaneously. In one part of the yard, workers assembled the bow section, complete with all interior framing, deck plates, and structural supports. In another area, crews built the stern section with the engine mounts and propeller shaft housing already installed. Midship sections, each 100 feet long and 3 stories tall, were constructed on separate assembly platforms. Each section was complete with wiring conduits, piping runs, ventilation ducts, and structural reinforcements before it ever reached the slipway. The double bottom, the internal hull structure that provided strength and housed ballast tanks, was assembled as complete units. Workers would build a double bottom section flat on the ground where they could work standing up rather than crawling in confined spaces. Once complete, cranes would lift the entire section and lower it into position on the growing hull. What had taken weeks of cramped, difficult labor in traditional shipbuilding now took days of efficient work in comfortable conditions. The same principle applied to deck houses, the structures above the main deck that contained crew quarters, the bridge, and other facilities. These were built as complete units in fabrication shops, with all interior walls, doors, windows, electrical fixtures, and plumbing already installed. When the time came, a crane would lift the entire deck house, weighing 30 or 40 tons, and set it in place on the deck. Workers would then weld it down and connect the utilities. A process that traditionally took months happened in hours. The welding itself represented a revolution in ship construction. Traditional ships were riveted, with each rivet requiring a team of 3 or 4 workers. One person heated the rivet to red heat in a portable forge. Another positioned it in the pre-drilled hole. A third hammered the head into shape, while a fourth held a bucking bar on the opposite side. The process was loud, hot, dangerous, and time-consuming. A good riveting crew could set perhaps 200 rivets in a shift. A single Liberty ship required over 1 million rivets, using traditional construction methods. Welding replaced all of that. An electric arc welding machine, operated by a single person, could join steel plates continuously along their entire length. The welds were stronger than rivets, created watertight seams without caulking, and weighed less because no additional material was needed. A welder could complete in one day what would have taken a riveting crew a week. The Liberty ship design called for approximately 3,000 individual welds of various lengths. With multiple welders working simultaneously on different sections, the welding could be completed in a fraction of the time traditional riveting required. Kaiser's yards employed thousands of welders, many of them women, working around the clock in shifts. The speed of construction created its own challenges. Quality control became critical. Inspectors moved through the yard constantly, checking welds with X-ray equipment and magnetic particle testing. Any defect meant stopping work on that section until repairs were made. The Maritime Commission maintained strict standards. Ships had to be seaworthy, had to pass sea trials, had to be safe for the crews who would sail them into combat zones. Speed could not come at the expense of basic structural integrity. The inspection process slowed construction somewhat, but it ensured that ships would not simply fall apart at sea. German naval intelligence watched American shipbuilding with growing concern, but their analysis remained rooted in traditional assumptions. Reports reached Berlin, describing new shipyards being constructed along the American coasts. Aerial reconnaissance photographs taken by long-range Luftwaffe aircraft showed the Richmond facility and similar yards in Maine, Maryland, and along the Gulf Coast. German analysts examined these images and calculated construction rates based on their understanding of shipbuilding. They counted slipways, the inclined structures where ships were built before launching. Richmond had 12 slipways. Traditional analysis said that each slipway could produce perhaps 4 ships per year, assuming a construction time of 3 months per ship. 12 slipways meant 48 ships annually from Richmond alone. Even if the Americans built 10 such facilities, that would be fewer than 500 ships per year. Substantial, certainly, but not overwhelming. U-boats could sink 500 ships if they maintained their 1941 operational tempo. What the German analysts missed was that the Americans were not using traditional construction schedules. The prefabrication system meant that most of the ship was built before it ever occupied a slipway. The slipway itself was used only for final assembly and launching, a process that took weeks rather than months. A slipway that would traditionally produce 4 ships per year was now producing 12 or 15. And the Americans were building not 10 yards but dozens of them, scattered across both coasts, each one employing tens of thousands of workers. The scale of the American effort was difficult to comprehend even for those who knew the numbers. The Maritime Commission had authorized the construction of 200 Liberty ships in the initial production run. This was soon increased to 300, then 600, then more. By mid-1942, the target was over 1,000 ships. By 1943, the program would expand to over 2,500 vessels. No nation had ever attempted shipbuilding on this scale. No nation had the industrial capacity, the raw materials, the workforce, or the organizational systems to build that many ships. Steel mills in Pennsylvania and Ohio rolled plate steel around the clock. The steel was shipped by rail to the shipyards in massive flat cars, each one carrying dozens of tons of plate. Pipe manufacturers produced thousands of miles of piping for steam lines, water lines, fuel lines, and ventilation systems. Engine manufacturers built reciprocating steam engines by the hundreds. The engines were not sophisticated, but they were reliable and could be manufactured quickly using existing machine tools and experienced workers. Electrical equipment manufacturers produced generators, switchboards, wiring, and lighting, fixtures in standardized designs that could be installed in any Liberty ship. The logistics of moving all these materials and components to the shipyards required its own organizational miracle. The railroads, already strained by military traffic and the general increase in wartime industrial production, had to schedule additional freight trains to carry ship components. Trucks moved materials from rail yards to shipyards. Warehouses stored materials in organized systems that allowed workers to find exactly what they needed when they needed it. Inventory control, a concept still relatively new in manufacturing, became essential. Running out of a critical component could shut down an entire section of the yard. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The human cost of this industrial mobilization was substantial but manageable. Shipyard work was dangerous. Workers fell from heights, were crushed by moving equipment, were burned by welding slag, or were injured in countless other ways. Safety programs reduced, but could not eliminate these hazards. The yards employed nurses and doctors who treated injuries on site. Serious cases were transported to hospitals that had established special wards for shipyard workers. Despite the dangers, workers kept coming because the wages were good, because the work felt important, and because everyone understood that the war could not be won without ships. The workers themselves developed a culture and identity around their labor. They called themselves shipyard men and shipyard women with pride. They competed informally between shifts to see who could complete work faster or more efficiently. They took pride in the ships they built, attending launches when their ship was completed and following news reports about vessels they had worked on. When a Liberty ship survived a torpedo attack and made it to port, workers who had built that ship felt personal satisfaction. When a ship was sunk, they felt the loss. Hull 444 began as a series of steel plates laid on the keel blocks in Bay No. 1 at 7:30 on the morning of November 12, 1942. By noon, the keel structure was complete, 300 feet of welded steel running the length of the slipway. Workers swarmed over the structure, positioning frames, welding supports, and laying deck plates. Overhead cranes swung prefabricated sections into position. Welders moved along the seams, their torches leaving glowing trails of molten metal that cooled into permanent bonds. By the end of the first day, the double bottom was in place. By the morning of the second day, the hull sides were rising. Prefabricated sections, each as large as a two-story house, were lifted by crane and positioned against the frames. Welders secured them. More sections followed. The hull took shape with startling speed, growing taller and longer with each passing hour. Workers inside the hull installed structural supports, laid piping, and ran electrical conduits. The work happened simultaneously at dozens of locations throughout the growing ship. On the third day, the deck was laid. Steel plates were positioned and welded to create the main deck surface. Cargo hatch openings were framed and reinforced. The deck houses arrived by crane, complete units with their windows already glazed and their interiors painted. They were lowered onto the deck, positioned precisely, and welded into place. Inside, other workers connected electrical systems and plumbing lines. The bridge structure, the highest point on the ship where the captain and officers would navigate, was installed complete with all its instruments and controls. The engine arrived on the fourth day, a reciprocating steam engine weighing over 140 tons. It came on a special railway car, was transferred to a shipyard crane, and was lifted over the side of the growing vessel. Workers guided it into the engine room through the opening that would later be covered by deck plates. The engine settled onto its mounts with a sound like thunder. Workers immediately began connecting steam lines, fuel lines, and the propeller shaft. The boilers followed, two large cylindrical vessels that would generate the steam to power the engine. They too were installed as complete units. By the morning of the fifth day, November 17th, the SS Robert E. Peary was complete. Workers had painted the hull grey and black, the standard merchant marine colours. They had installed the masts and booms used for loading and unloading cargo. They had stocked the galley with food, filled the fuel tanks with oil, and loaded the crew quarters with bedding and supplies. Maritime Commission inspectors walked through the ship checking systems. Everything worked. The engine turned when steam was applied. The electrical systems functioned. The pumps moved water. The ship was ready for launch. At 2 p.m. on November 17th, 4 days and 15.5 hours after the keel had been laid, the SS Robert E. Peary slid down the slipway into San Francisco Bay. Workers cheered. Horns sounded across the shipyard. Newsreel cameras captured the moment. Henry Kaiser stood watching, knowing that his workers had just proven something that would change the war. They had built a complete ocean-going merchant ship in less time than it took to sail one across the Atlantic. The news reached Washington within hours. Maritime Commission officials, who had watched the construction with a mixture of hope and skepticism, now had proof that mass-production shipbuilding worked. The news reached London, where British officials struggled to comprehend how a ship had been built faster than some Royal Navy vessels took to refuel and resupply. And the news reached Berlin, carried in intelligence reports that German naval staff read with growing disbelief. Mathematics had changed. If the Americans could build a ship in 5 days, they could build 70 ships per year from a single slipway. Richmond had 12 slipways. That was 840 ships per year from one yard alone. The Americans had dozens of yards. The calculation that had seemed so solid that U-boats could sink ships faster than they could be built was revealed as dangerously wrong. The Americans were not building ships at peacetime rates. They were not even building them at emergency rates comparable to British production. They were building them at industrial mass production rates that had no historical precedent. German U-boat commanders, operating in the Atlantic and hunting convoys, began reporting strange experiences. They would sink a merchant ship, documenting its tonnage for headquarters. Weeks later, they would encounter another ship with an identical profile, the same dimensions, the same appearance, even the same general cargo capacity. At first, they assumed these were sister ships from the same builder. But the frequency of encounters suggested something else. The ships were not merely similar, they were identical, mass-produced, built from the same plans, with the same components, in the same configuration. One U-boat commander reported sinking 5 ships over 2 months that were so alike he initially thought his patrol reports contained errors. They were not errors. They were Liberty ships, turned out by American yards like automobiles from an assembly line. The SS Robert E. Peary sailed from San Francisco Bay on December 2, 1942, bound for the Atlantic with a cargo of war materials. The ship made the voyage through the Panama Canal and across to Britain without incident, delivering its cargo to ports that desperately needed resupply. It returned to the United States, loaded another cargo, and sailed again. Over the next 3 years, the Peary would complete 5 round-trip voyages across the Atlantic, carrying thousands of tons of supplies to support the war effort. The ship survived the war intact, one of the fortunate Liberty ships that never encountered a U-boat or struck a mine. But the Peary's importance was never its individual service record. It was the proof of concept. After November 17, 1942, no one could claim that building ships in a matter of days was impossible. Kaiser's yards and others across the country shifted into maximum production. The average construction time for a Liberty ship dropped from the initial estimates of several months to approximately 42 days, from keel laying to launch. Some yards achieved even faster times. The record set by the Peary stood, but dozens of ships were completed in 7 to 10 days. Hundreds were built in under 30 days. The production numbers became staggering. In 1942, American yards launched 346 Liberty ships. In 1943, they launched over 1,800. In 1944, another 1,000 ships joined the merchant fleet. By the end of the war, American shipyards had constructed 2,710 Liberty ships, along with hundreds of other merchant vessel types, including faster Victory ships, tankers, and specialized cargo vessels. The total tonnage produced exceeded 27 million gross register tons. German U-boat commanders watched this fleet grow with increasing desperation. Their patrol reports documented the problem in stark terms. One commander, operating off the American East Coast in early 1943, reported observing a continuous stream of merchant vessels heading for convoy assembly points. He counted more than 30 ships in a single day, far more than his boat could possibly engage. Another commander, hunting in mid-Atlantic convoy routes, reported that the convoys themselves had grown larger. Where a typical convoy in 1941 might consist of 30 to 40 ships, by 1943 convoys often numbered 60 to 80 vessels, with escort forces that made attack suicidal. The strategic mathematics that Admiral Dönitz had relied upon collapsed entirely. His target of 700,000 tons sunk per month had been based on the assumption that the Allies could not replace losses faster than U-boats could inflict them. But American production alone was launching more than 1 million tons of new shipping every month by 1943. Even accounting for British and Canadian production, the Allies were adding tonnage to their merchant fleet faster than the Germans could sink it. The tonnage war, the fundamental strategic goal of the U-boat campaign, was lost. Dönitz refused to accept this reality for months. He ordered more U-boats built, more patrols sent out, more aggressive tactics employed. German shipyards constructed new submarines at remarkable rates, completing over 200 boats in 1943 alone. But submarines took months to build, required trained crews, and consumed scarce resources that German industry desperately needed for other purposes. Each U-boat represented steel that could have built tanks, skilled workers who could have produced aircraft, and diesel fuel that ground forces needed. The resource allocation made less sense with each passing month, as it became clear that the submarine campaign could not achieve its strategic objectives. The human cost mounted on both sides. U-boat crews, young men who had volunteered for what they believed was the elite service of the Kriegsmarine, died in their steel coffins as Allied anti-submarine warfare improved. Of the approximately 40,000 German submariners who served during the war, over 30,000 were killed. The casualty rate, 75%, was the highest of any branch of any military service in the entire war. These men died knowing that their sacrifice was achieving nothing, that every merchant ship they sank was replaced by 2 more, that the Atlantic was becoming an Allied highway rather than a German barrier. Merchant sailors on the Allied side paid their own terrible price. Over 30,000 British merchant seamen died during the war, killed when their ships were torpedoed, bombed, or mined. American merchant marine casualties exceeded 9,000 dead. These men were civilians, not military personnel, though they served in combat zones and faced combat dangers. They sailed knowing that U-boats hunted them, that a torpedo could strike without warning, that survival in the cold Atlantic water was measured in minutes. They sailed anyway because the supplies had to get through. The Liberty ships themselves proved to be adequate vessels, though far from perfect. They served their purpose of moving cargo across oceans in massive quantities, but they had significant limitations. The reciprocating steam engines were reliable but slow, limiting the ships to about 11 knots in calm seas and less in rough weather. This made them vulnerable to U-boats, which could travel faster on the surface and maneuver more quickly. The welded construction, while faster than riveting, created problems in cold water. Some Liberty ships developed cracks in their hulls when sailing in North Atlantic winter conditions. A few broke apart catastrophically when cracks propagated through continuous weld seams rather than stopping at riveted joints. The most famous structural failure was the SS Schenectady, which broke completely in half while docked in calm water in Portland, Oregon, in January 1943. The ship had been in service less than 2 months. Investigators found that the welds had become brittle in cold temperatures and that stress concentrations at hatch corners had initiated cracks that propagated catastrophically. The incident led to design modifications. Engineers added crack arresters, steel straps that would stop crack propagation. They modified hatch, corner designs to reduce stress concentrations. They improved welding procedures and inspection protocols. These changes reduced but did not eliminate the structural problems that plagued some Liberty ships throughout their service lives. Despite these issues, the Liberty ships succeeded in their primary mission. They moved cargo in quantities that no previous merchant fleet had ever achieved. Convoys arriving in Britain in 1944 might unload more supplies in a week than had arrived in an entire month during 1941. The Soviet Union, receiving supplies through both the Arctic convoys to Murmansk and the longer route through Iran, obtained American trucks, aircraft, food, and raw materials that kept its war effort functioning. The invasions of North Africa, Sicily, Italy, and eventually Normandy all depended on logistics enabled by the mass-produced merchant fleet. The invasion of Normandy in June 1944 required more than 5,000 vessels of all types. Among them were hundreds of Liberty ships carrying the fuel, ammunition, food, vehicles, and equipment needed to support the Allied armies in France. Over the following months, as those armies fought across France and into Germany, a continuous stream of supplies flowed across the Atlantic and through French ports. Liberty ships, built in American yards by workers who would never see combat, enabled the fighting effectiveness of every Allied soldier in Europe. The Pacific War created equally enormous logistical demands. American forces island-hopping across the Pacific needed supplies transported over distances that dwarfed the Atlantic routes. From American West Coast ports to forward bases in New Guinea or the Philippines might be 7,000 miles. Every gallon of fuel, every round of ammunition, every ration, every spare part had to travel that distance by ship. Liberty ships and their faster successors, the Victory ships, made this possible. They created the logistics network that allowed American forces to advance across the Pacific while maintaining offensive operations in Europe simultaneously. Japanese military leaders, watching American logistics in the Pacific with the same growing horror German commanders felt in the Atlantic, recognized that they faced an enemy whose industrial capacity was simply incomprehensible by Japanese standards. Japan had built approximately 600 merchant ships of all types during the war years. American submarines and aircraft sank over 2,000 Japanese merchant vessels, destroying Japan's ability to move resources from conquered territories to the home islands. The mathematics worked exactly opposite to how the Germans had hoped in the Atlantic. Japan could not build ships faster than America could sink them, and Japan could not sink American ships faster than American yards could build them. The workers at Richmond and the other shipyards read about the war in newspapers and heard about it, on radio broadcasts. They learned about the Normandy invasion, and the liberation of France. They heard about American victories in the Pacific. They knew that ships they had built were part of these operations, carrying the supplies that made victory possible. Some workers had family members serving overseas. A welder might have a son in the army in France, supplied by ships the father had helped build. A crane operator might have a husband in the Navy in the Pacific, protected by destroyers whose steel had been shaped in the same yard that produced merchant vessels. When the war ended in August 1945, the shipyards faced an uncertain future. Kaiser's Richmond facility had employed over 90,000 workers at peak production. Within months of the Japanese surrender, employment dropped to a few thousand. The massive yards that had produced ships around the clock fell quiet. The cranes stopped moving. The welding torches went dark. Many workers returned to peacetime occupations or started new careers with skills learned in the yards. The women who had welded ship hulls found that peacetime employers often refused to hire them for similar work, preferring to reserve such jobs for returning veterans. The industrial mobilization that had proven so effective in wartime dissolved rapidly in peace. The Liberty ships themselves had varied fates after the war ended. Some were sold to private shipping companies and continued operating commercially for decades. Others were placed in reserve fleets, anchored in bays and rivers across the United States as a strategic reserve in case they were needed again. The reserve fleets, sometimes called mothball fleets, contained hundreds of Liberty ships riding at anchor, slowly deteriorating from neglect and weather. A few were reactivated for the Korean War in the early 1950s. Most were eventually sold for scrap, their steel recycled decades after it had first been formed into hull plates in wartime. America. A handful of Liberty ships survive today as museum ships and memorials. The SS Jeremiah O'Brien, berthed in San Francisco, is maintained in operating condition and occasionally sails under its own power. The SS John W. Brown in Baltimore also remains operational. These vessels serve as physical reminders of the industrial achievement they represent, allowing visitors to walk through the cargo holds and engine rooms and crew quarters, to see the cramped conditions and simple equipment, to understand that these ships were built for function rather than comfort or longevity. The strategic lessons of the Liberty ship program shaped post-war military thinking about industrial mobilization and logistics. American military planners recognized that future wars would be won or lost based on industrial capacity and the ability to sustain military forces with adequate supplies. The Cold War military buildup included not just weapons production but also merchant fleet maintenance, strategic material stockpiles, and industrial base preservation. The assumption was that any major war would require rapid industrial mobilization, similar to what had occurred during World War II. For the German U-boat force, the Liberty ship represented the moment when their strategic assumptions proved fatally wrong. The tactical excellence of U-boat crews, their courage and skill, meant nothing against an enemy who could replace losses faster than they could inflict them. The technology of the Type 7 U-boat, which was adequate for its intended mission, could not overcome the fundamental disparity in industrial production. Individual commanders like Wolfgang Luth or Otto Kretschmer might sink dozens of ships and be celebrated as aces, but their successes were tactical achievements in a strategic defeat. The post-war interrogations of German naval officers revealed a consistent theme. They had understood their mission, believed in their technology, and fought with determination and skill. What they had not understood was the sheer scale of American industrial capacity. German intelligence had provided accurate information about American shipyards being built and ship production increasing, but the numbers seemed so large that they were dismissed as impossible or as Allied propaganda. When U-boat commanders encountered the reality, when they watched convoy after convoy pass with more ships than they could possibly engage, the psychological impact was devastating. They had been fighting an unwinnable battle, committed to a strategy that mathematics had already proven would fail. The workers who built Hull 444 and the thousands of other Liberty ships were not soldiers, but their contribution to victory was as essential as any combat action. They worked long hours in dangerous conditions for the duration of the war. They applied American industrial know-how and mass production techniques to a problem that had seemed unsolvable. They proved that factories could win wars as decisively as armies and navies. When the SS Robert E. Peary slid into San Francisco Bay after 4 days and 15.5 hours of construction, it carried a message that would echo across the Atlantic to every U-boat pen and every German naval headquarters. The message was simple but overwhelming. America could build faster than Germany could destroy. The tonnage war was over before it truly began, decided not by naval combat or tactical innovation, but by production capacity and industrial organization. The welders and crane operators and electricians at Richmond and the dozens of other shipyards had won a victory that no U-boat commander could reverse, no matter how skilled or determined. They had built the bridge of ships that connected America to its allies, that sustained the war effort, that carried the supplies and equipment necessary for ultimate victory. The Liberty ship was never meant to be a beautiful vessel or a technological marvel. It was meant to be adequate, mass-produced, and available in overwhelming numbers. In that mission, it succeeded completely. The program represented American industrial democracy at its most effective, harnessing the productive capacity of a continental economy and the labor of millions of workers to create the tools needed to win a global war. The 3-day construction time suggested in wartime propaganda was an exaggeration, but the truth was remarkable enough. Ships that should have taken a year were built in weeks. An industrial nation fully mobilized proved capable of achievements that seemed impossible by any previous standard. That morning in November 1942, when the welders began work on hull 444, they were starting just another shift. By the time the SS Robert E. Peary was launched less than 5 days later, they had helped change the mathematics of the war. The Battle of the Atlantic would continue for more than 2 more years, and thousands more ships and men would be lost. But the outcome was no longer in doubt. America had proven it could build faster than U-boats could sink, and that proof meant the Atlantic would remain open, Britain would survive, and the invasion of Europe would proceed on schedule. The Liberty ships, mass-produced and unglamorous, had become the weapons that won the tonnage war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.